Thank you for your introduction, Niels. So yes, today I will talk about iteratively proving products ideas, but also other ideas. So first, let me introduce myself. I'm Bas van Berkel, and I'm working as a data scientist in the data science assortment team, which as a team is slowly moving towards more of a focus on product discovery, and hence also the topic of this talk. In the past years, I've worked first on best offer, and after that, assortment grids, and currently working on a set of smaller projects within the assortment and promotions domains. So in the talk, I plan to talk about good steps in starting a new project, starting a new product, or simply when you're having new ideas within your product, how you can slowly get those in there. And most of you probably already use some of these steps implicitly when going from your ideas to production. But in the talk, I hope to convince you to start small and scope down, to validate ideas through experiments, and to stepwise increase your ideas into where you want to end them up, want to have them end up like this small leaves growing into a big, nice oak. So first, how did this came about? A short introduction. So last year, as a team, a few of the projects and products we were building, we ran into blockers while we were already heavily invested into what we were doing and months into the process. And what we ran into blockers such as unexpected dependencies, data availability on a bigger scale, legal risks for some of the problems from some of the projects, and other unforeseen complexities in more in our algorithms. But you could see them also as technical complexities. And what connected those issues is that often when starting a new project, we jumped in too quickly into starting it at scale, and we didn't take enough time to explore the risks and the blockers just mentioned. So as such, we realized that we have to spot potential blockers or risks earlier in the project or in building a product. So to spot the risks earlier, we came up with an iterative process. And the first step in that is collecting all the ideas relevant to your team, prioritizing those and working on the ones which have the biggest opportunities. And after that, we start for those with the biggest opportunities. We start with a proof of concept. After the proof of concept, we run a small experiment to prove the assumptions we have about that idea. And after that, the next phase is to make it bigger in the prototype. And then again, experiment bigger because you want to have more proven results. And if that's successful, then you can build it into a minimum viable product, which can slowly grow into a big permanent product. So this graph is to kind of show my ideas of scale and the different phases. As there are hundreds or even thousands of potential ideas for projects or products that can improve bol.com, I strongly believe that we only get to the best of those ideas when we try a lot of them. But we don't have the time to try everything completely. So we have to be critical in deciding which we want to work on first and how much time we want to spend on validating them. And the graph kind of shows an indication how 100 ideas can flow into one product. So you expect to have 100 of ideas, try 20 of them in a POC, of course, not all at the same time, but one after another. Then from that, go into 5 prototypes roughly, 2 MVPs, and one of them can become like a product. And as time frame, you kind of can see an idea forms in a few hours. A POC can be a few days, a prototype weeks, an MVP months, and a product hopefully forever, if it's a successful idea. Before going into each phase, either a POC or a prototype or an MVP, there are a number of important steps. As a team, we made a few checklists for this, but I'll just highlight the most important points. So it's important to think about questions such as, what's the goal of my idea? What will we make? Who will be involved? Both stakeholders as who will be working on it. What data, though that's mostly a data science perspective on it, and how can we validate our idea? So I highlight 3 of those on the next slides. the goal, the how, and the experiment. So first, the goal. It's important to know what you want to learn. Do you want to test the technical working of a complicated technique or algorithm? Or do you want to know how users will react to a certain feature or solution you're building? Or do you want to know the potential of an idea by analyzing data in an earlier phase? So based on this, you can define the goal of your phase. You can set KPIs accordingly and kind of find out how you align with strategy of the company. But you can also get learnings you want to measure or achieve them by. Next to the goal, before starting each phase, it's important to think of the how. And this is, I think, the most fun part. We all like what we're doing, and in that, we really like to figure out how can we do that. What will you build to validate your goals? Which solutions are you going to try? Are you going to try one solution or multiple solutions? And I won't dive into how you have to do the how, because all of you are experts in what you're in your topics. So who am I to talk about that? But there is, I think, one big risk we've noticed during the POCs we've done so far, and that is that because while you're working on something, you come up with a lot of new ideas. We tend to kind of add stuff to POCs naturally, or to a phase we're in. We tend to add more and more and more, and this can lead to forever continuing phase or scope creep, so to say. And this is really important to scope. It's really important to scope what you're building, both in content but also in time. So set, like, if you're starting with something, set that you will do it in one day and stick to that. Don't overextend that, or set that you will do only this, and even if you have some time left, just stop there, and because you can use this time also for other things. Because in the end, it's most important to see how will what I'm testing work towards the goal or objective. How am I going to prove that with the how? So I've mentioned experiments before, and the idea of the aim of the experiment is to validate your assumptions and to prove them, and by getting some tangible evidence for your idea. But determining the right experiment at each phase is often one of the more challenging things. And when mentioning experiments, at Bol.com, we often think of A/B experiments. Maybe this sounds strange coming from a data scientist, but I think often we can do without one. So especially in those earlier phases, we don't need a significance level of 5%, smaller than 5%. In those earlier phases, this next slide. In those earlier phases, we can find suiting experiments which are of a much smaller level. And a lot of these we already do at different places on Bol.com. So we can do qualitative interviews with users. This is mostly actually relevant in the ideation phase already, before starting to work on something. We can simply take a look at what we built. That can be the experiment. If we are testing something technical, then we don't have to do an experiment other than experimenting with that technical thing. We can do a user experience test, and that can be both to customers, but it can also be for internal tools to internal customers. And you can, in earlier phases, also even do this on a non-working mockup. You don't have to have a full working product for that. We can validate results by experts. So that's the classic data science one. So the grapes are kind of as an example. Would I do some image recognition on this? Then to find which grapes are ripe, then I'd need an expert to help me tag the ones which are ripe grapes, because I'm no expert on this. And finally, the classical A/B experiments. But most importantly, that this is to show there's a lot possible. So there's much more than this list. Oh, I get a bad network quality, so I hope all of you are still hearing me. So to bring everything I talked about together, I'll shortly explain how we applied this in what we're doing now as a team on promotions. So first, a bit of background on that. Currently, when we do promotions on our website, this involves a lot of manual work. And together with the campaigning team, we've been thinking, how can we automate this? So what we realized is that the promotion always will need products or globals in it, whichever way we will automate this. And as such, we decided first to focus on that. Another thing we realized is that sorry, I'm skipping a bit ahead now. So we wanted to focus first on determining which globals end up in a promotion and automate that. And our goal was mostly to automate it and less so to make the perfect algorithm the first time around. So we decided to build a simple algorithm purely based on the amount of purchase. And we scoped this down to awareness promotions because price of promotions have legal issues with showing different prices. In this case, we were able to do an A/B experiment, though it wasn't significant because, and we knew this beforehand, because we would only get a few 10,000 impressions, but the data would be really valuable to us. So the POC gave some valuable lessons on how easy it is to automate this process, and it's not so easy, but to semi-automate it, it seems a nice opportunity. And as this was the first experiment with promotions, we also, or with content of promotions, we also learned a lot of lessons there. So now the next steps are to iteratively scale this up, and for Father's Day we have 2 more small tests planned, and after that we will make more plans to scale it up to something bigger. Okay, a small recap to round everything up. So I hope I was able to bring across that by starting small, we are able to test a lot of ideas. It's important to scope, and most importantly, experiment along the way by doing simple experiments where possible. So by doing this, we can grow an idea into a full-blown product 1 step at a time. And because we tested risks, we have a smaller chance of running into surprises which can halt the success of our ideas. So there's also some interesting related reads. The Buchan Sprint is really interesting if you want to know how you can in 1 week solve and test big ideas. And the other one is a good one on definitions on POCs and prototypes. So thank you, everybody. And I'll now look to the questions and answer them.
Thank you, Bas. Really nice presentation. Good overview of the topic. I think it's really, I found it really interesting myself. I don't see any questions yet, but if there are people in the audience who still have questions, because we at the moment have 66 people viewing, so I can't believe there are no questions at all. That simply doesn't happen, right? So let's wait for a few minutes, and otherwise we can take it offline in the Google Hangouts. Because there also we can discuss this further. So let's give it a minute. Maybe people are very anxiously typing right now. Well, I guess there are no concrete questions at the moment. Oh, wait, one is just coming in. Yeah.
Yeah, so this is a good one. So how do we split the time between the delivery and the discovery experimentation of our ideas? So what we notice is indeed by we're also still learning with this. So we're doing it more and more, and I think we've done 10, 12 POCs or something now. So by what we see is that often first we really did a lot before and afterwards, like before care and after care, but slowly we're starting to learn to better scope what we are doing, and also what we are aim at in the future is to actually have the focus be. So now the focus is for the data scientist to both kind of introduce the idea, then work on it, and then finish it off. And our aim is to split this a bit more between the different roles. So I think in the more classic IT approach, having the PO and the BA work more on the before and after phases, and the actually scope POC being done more by the software engineers makes sense.
All right. There's another one just come in, but we're actually a little bit out of time. Maybe you can answer it in a few seconds still.
Yeah, so I think, well, first of all, I think A/B tests, they can fail. If they fail, you get a nice result that you know you should focus on something different or reiterate on something you're doing. And I think one of the more important things we learned is that an A/B test is often really difficult to set up. So don't make it too big before setting up an A/B experiment, or try something smaller first in something different than an A/B experiment.
All right. I think we should leave it at this because we're out of time. There's one question left, but we can take that, I guess, into the Google Hangouts. Thank you for your presentation, and thanks everyone for attending. Wish you all good luck in the next sessions, and see you later.